In a geometric series, you often see that n starts at 0 and then goes all the way to infinity. So if you have n starts from 1, so from n from 0 to infinity, you have a times r to the n. And then when n starts from 1, you need to do a minus 1 in the power. Because when n is equals to 1, 1 minus 1, you go back to 0 when n is equals to 0. All right, so how about this geometric series? So let's say given, I want to match this red. Okay, let's go back and then match that red. And then we have summation. N goes from 1 to infinity. And then this time I will give you a sine 3 to the nth power. Okay, I gave you a 1 now. What if you go back to a 0? So if you go back to start from 0, you draw a summation, n goes from 0 to infinity, and then this one I will have a sine 3, and then this will be a n plus 1. Okay, let's take a look. When n is equals to 1, the first term is the first power, right? This one, when n is equals to 0, and then you add 1 to it, you also start at the first power. So in the very first term for both series, the very first term, you have the first power, okay? And then what do we have for the n plus 1? Because this one, we don't have an n plus 1. So since we study how exponent works, so for n plus 1, I can do a summation. N goes from 0 to infinity. I can do sine 3 to the n, and then times sine 3 to the first. You have the same base, then all you need to do is you add the exponent, right? And then the first power never change. You can pull that out, so you can have a sine 3 first power, and then a geometric series, n from 0 to infinity, and then you have a sine 3 and then n. So now you have a geometric series, and then the common ratio is sine 3. Is sine 3 greater than 1? No, the absolute value of sine 3, this is less than 1. This is less than 1. That means the series converges. How do I know? Do I need a calculator? The answer is no, you don't need a calculator. So just simply scratch the graph of sine. So you have the x-axis and the y-axis, right? Y and then x. And then the sine, you have this graph. And then on the other side, you have that, and like this keeps on going, and then the range of sine is bouncing between 1 and -1. So for sine of 3, sine of 3 must be between -1 and 1. That you take the absolute value of that quantity can never be greater than 1. Okay, so now we know that the series converges, and then we can find the sum. The sum is a divided by 1 minus r. A is sine 3 to the first power, and then divided by 1 minus sine 3. Okay, they give me a 3, not a 3 degree, then I will use the radian mode in my calculator. So set your calculator in radian mode. If they are looking for the exact value, then that is your final answer. That is the exact value. So using radian mode, this one I got 0.1643 using radian mode. All right, so that is the end of this video. And then in the next video, I will show you the geometric series for a repeating decimal. See you there.